If you're on number 14, you're very likely starting to get a better understanding of what we're doing to solve for the variables in these 4.3 exercises. We're either multiplying or we're dividing by a number. When the number is considered to be on top, that's a multiplication operation. Then we solve it by dividing by that same number. And when the number is considered to be on the bottom, that's a division operation. We solve it by multiplying on the same number to the top. Now, in this example, this 1/6 times w is greater than or equal to 2.5. I'm going to make up my own example. I'll do 1/8 x is less than or equal to 2. And so in this example, what we have is we have a fraction being multiplied by a variable x. Now, this 1/8 times x, you can actually multiply that out. So there's two ways of doing this. You can multiply that 1/8 out. 1/8 times x. We can actually solve that out, put that x over 1, turns it into a fraction. 1 times x is x. 8 times 1 is 8. And so this simply becomes 8 over x, something that we're much more familiar with seeing, because 8 over x over 8, to solve that out, well, then we would just multiply by 8, because the 8 is on the bottom, and to get an 8 on the top, we just multiply an 8 to the top. And then we would just multiply that 2 by 8 as well, and we'd get that x is less than or equal to 16. So if you actually multiply that out, you'll see that because there's a 1 on the top here, multiplying it by x, it simply gives you just x over 8. Another way of viewing this problem is that this 1/8 is a fraction, and we can take any fraction and multiply it by its reciprocal, and we will get 1. So the reciprocal of 1/8 is 8 over 1, or just 8. 1/8 times 8, that's like having an eighth. And then multiplying it 8 times, so there's the first eighth, second, third, fourth, 5, 6, 7, 8, gives you 1. And so if you saw that as a fraction and you were like, well, I'll just multiply by its reciprocal, 8 over 1 equals 1. And then I'm going to multiply the same thing over here, this 2, by 8 over 1, which is really just 8. Then you'll get the same answer, that x is less than or equal to 16. So either way that you saw it will get you to the same answer. And either way, you're going to need to multiply by 8. So using that same kind of knowledge, you're going to be solving out this inequality in exercise 14. We have 1/6 w in this case. So we can either turn that to w over 6, or you can view it as a reciprocal. You can view it as keep it as a fraction, but either way, you're going to need to multiply by 6 in order to solve it out. And multiplying it by 6 in either section is going to give you just 1w. And then after that, you'll need to take that 2 5/10 and also multiply that by 6. Well, that's like 25 times 6, and that 25 times 6 is 25, 50, 75, 100, 125, 150. And then we have one number past the decimal, so it's going to move in one time. It's going to equal 15. And then following that, you'll just go ahead and graph it. Just remember, if the number can equal a certain number, we're going to use a closed circle. If it cannot equal that number, we use an open circle. That means that number is not the solution. And then if the variable is greater than, it's always to the right. If the variable is less than, it's always to the left. You can kind of also remember less than, left, both start with the letter L. So if the variable is less than, go to the left. Okay, exercise 15. We have that 7 is less than 3 5/10 k. Let's do my own example. I'm going to do 9 is less than 4 5/10 y. 9 is less than 4 5/10 y. The number that's attached to the y, the one that we're trying to get rid of, is 4 5/10. If we have 4 5/10 on the top, we need to get a 4 5/10 on the bottom. It was originally a division problem, so I'm going to divide in order to get a 4 5/10 on the bottom. Which means I'm going to divide the 9 by 4 5/10. 4 5/10 y divided by 4 5/10 leaves you with just y. divided by a positive number, so the sign is going to stay the same. If it was negative, we would flip it. And then 9 divided by 4 and 5/10. Some of you guys might recognize right away that 4 and 5/10 is half of 9. So 9 divided by 4 and 5/10 would be 2. But if you didn't recognize that right away, then we can do 9 divided by 4 and 5/10. Move this decimal over once, and then move the imaginary decimal here over once also and add a 0. And then 45 wholes goes into 90 2 times with a remainder of 0. And so here my answer would be 2. 9 divided by 4 and 5/10 is 2. And then y, we can describe y as saying that y is greater than 2. If y is greater than 2, that means I'm going to use an open circle since y can't equal 2. And then if it's greater than, it's going to go to the right. Alrighty, exercise 16. For exercise 16, we are being asked to solve for x just like all our other problems, but with this one, what the difference is that we have a fraction over on the other side. And so this is the first time we're seeing a fraction here. I think that you will probably recognize right away that we have the number we're trying to get rid of is a 3, and since it's on top of the fraction, we're going to put a 1 on the bottom, which means to divide by 3. Now, if I am going to do that to the left side, that means I need to do that to the right side as well. Well, in my example, I'll do the same thing. I'm going to use a different number. I'll do 7 over 3. And I'm going to divide both sides by 2 in my example. Just like I did over on the left side, I divided both sides by 3. Here I'm going to divide both sides by 2. But I'm not going to put the 2 underneath here. Technically I can. I'm not going to though. What I'm going to do instead is I'm going to actually use the traditional division sign. I'm going to divide by 2. This divided by 2 is the same thing as this divided by 2, just written in 2 different forms. And dividing by 2 is the same thing as divided by 2 over 1. And now I'm dividing fractions. And what do we do when we divide fractions? We keep, change, flip. So it's going to become negative 7 over 3 times 1 over 2. And negative 7 times 1 is negative 7. And 3 times 2 is 6. So this becomes negative 7 over 6, which is negative 1 and 1/6. So what I want you to take away from that isn't necessarily the answer of this, because that's not going to help you at all, but I want you to take away that I divided by 2, just the same way I divided by 2 on this side, but I wrote it traditionally in this case, and then made sure to do a keep, change, flip to get my answer. So you're going to be doing that same thing to solve out this inequality that we have here, 3x is less than or equal to negative 5 over 4. And following that, you'll graph your solution, and you'll be all done with that problem. So you've actually... that actually isn't too tough of a problem. It just seems kind of tough because we're dealing with a fraction. And so because of what we've been doing, we want to just put a 3 underneath here, but then you have a fraction within a fraction. And so that's where we're going to need to just do it a little traditionally. Exercise 17. Here we are dealing with dividing decimals because we're starting out with a multiplication problem. So, but again, nothing too crazy going on here. I'll do an example for you that's going to be kind of similar. Let's do 3 6/10 negative 3 6/10 x is less than or equal to 14 4/10. So attached to the x, negative 3 6/10. Is it on the top or the bottom? It's on the top, which means I need to get one on the bottom underneath it. So in order to get a negative 3 6/10 on the bottom, I can simply put my fraction line, which is a division, and put that same number underneath. Negative 3 6/10 divided by negative 3 6/10. Well, that is just going to leave me with 1x. And then I divided by a negative number, so it's really important that I notice that I'm going to have to flip the sign because I divided by a negative 3 6/10. And I'm going to do the same thing over here. I'm going to divide by negative 3 6/10. I'm going to work this out by putting 14 4/10 on the inside of my division sign, and then 3 6/10 on the outside. This is a positive number divided by a negative number, so I'm going to put my negative sign down just so I don't forget it later. I'm going to move my decimal over here once, which means I'm going to move this decimal over here once. So my decimal is going to be right here when I solve this out. And then I have to ask myself, how many times does 36 go into 144? Well, 36 into 144 goes in 4 times. 4 times 36 is going to be 144, so I'm going to have a remainder of 0. So all in all, x is greater than or equal to negative 4. X can equal negative 4, so I would use a closed circle. And it's also greater than negative 4, so I'm going to go to the right. Now just keep in mind, though, this is just my example. You're going to have to come up with the solution to this problem on exercise 17 using the same kind of technique I used with my example. Just make sure to check whether you're dividing a positive or a negative. Are you going to have to flip the sign, and so on. But I just wanted to give you, to take away from this, a reminder on how to divide the fractions. I'm sorry, how to divide the decimals. And then if we have dividing decimals, it makes sense that we're also going to have multiplying decimals. So in this problem, exercise 18, we have a 11 and 3/10 is greater than b over, or b divided by 4 and 3/10. What's attached to the variable of 4 and 3/10? Is it on the top or the bottom? It's on the bottom, which means we need to get one to the top. So we're going to multiply by 4 and 3/10 over 1. That's going to equal 4 and 3/10 b over 4 and 3/10. 4 and 3/10 b divided by 4 and 3/10 is going to just equal b. I'm going to keep it on that same right side. I see some people flipping it over to the other side. Make sure you're not doing that unless you're also going to flip the comparison sign. And so now I'm going to drop this down because I multiplied by a positive number. I'm not going to need to flip the sign. And then now I need to determine what is 11 and 3/10 times 4 and 3/10, just like I did to the right side. Well, I'm going to multiply this out if it was just regular multiplication. So 113 times 43, that's going to be 933. Skip a spot. 4 times 3 is 12. Bring the 1 up. 4 times 1 is 4, plus 1 is 5. 4 times 1 is 4. Add your numbers together. And I get 4,859, but I have 2 numbers past the decimal. So I'm going to move this in 2 spots, 1, 2. And I get as an answer that 48 and 59 hundredths is greater than b. That's going to be my solution. So I actually worked this one out for you because I also want to show you how to find where this goes on the number line. So I see a 48, that these all have 48. And then the one that has the 5 in the tenths place is going to be this one right here. But that's not 48 and 59 hundredths like we're looking for. That's 48 and 5/10. And then the next number that I see that's visible is 48 and 6/10. Well, this is kind of like $48.50. And over here it's kind of like $48.60. But we don't jump from 48.50 to 48.60. We go 48.50, 48.51, 48.52, 48.53. And so I hope you're seeing here that between 48 and 5/10 and 48 and 6/10, between these 2 tenths, there is all of these values that are in the hundredths place, because these values all represent a number here in the hundredths place. So those would be the pennies to your dimes, you can think about it as. And so you're going to be looking for 48 and 59 hundredths, or think about it as $48.59.